Page 2 of Unit 1. So now using a density of something we haven't really dealt with. It's a liquid called ethanol or ethyl alcohol. We know that it has, according to this, has a density of 0.789 grams per cubic centimeters. What that means is there's 0.789 grams in every 1 cubic centimeter. Or you could also look at it as there's 1 cubic centimeter per every 0.789 grams. Why would you want to look at it two different ways? Well, it depends on what they're asking you. They're telling you that you have 90 cubic centimeters of this stuff, and what they really want to know is how many grams you have of this stuff. What is the mass? So I'm going to multiply this by a fraction, a factor that relates the mass and the volume. Which one am I going to use? The one that lets me put cubic centimeters on the bottom so that it crosses off and leaves grams on the top. So I can set up my units before I go get my numbers. Now I see that I would put this on top, 0.789 grams per 1 cubic centimeter. This ends up being a multiplication, 90 times 0.789, and I'm going to get approximately 71, everything crossed out except grams. If you wanted to keep 71.0 or 71.01, that's okay. Where we round isn't an issue, it's whether we know how to do the correct math. Next is what's the volume of 45 grams. If I have 45.0 grams, same idea. I need to set it up in such a way that grams disappears. I'll put that on the bottom so that it crosses off, and I want cubic centimeters. So I follow this lead here. 1 cubic centimeter is 0.789 grams. When you have a fraction, 45 times a fraction, 45 times 1 divided by 0.789. Ultimately, it's just 45 divided by 0.789. Let me just redo that. I think I missed 5 divided by 0.789. And you should get 57 or 57.0 cubic centimeters or milliliters. What would happen if you place ethanol in water? Well, let's look at ethanol's density. It's 0.789. We need to remember that water's density, by definition, they made it up this way. Water equals 1 gram per milliliter. So if you put something with less than 1, it will float. If you put something greater than 1, it will sink. So what would I have said? I'll just say this one. Ethanol would float in water because its density is less than the density of water. Gold is a density of 19.3 grams per cubic centimeter. A cube of gold. Okay, so the first one is just a cube, 2.34 by 2.34 by 2.34. What's its volume? Just multiply those three numbers. Suppose I should have centimeters, centimeters, centimeters. 2.34 times 2.34 times 2.34. I'm going to just redo that. I think I did 2.34. 12.81. I'm not going to be picky about rounding on this one, just on the quiz. But my logic here would be I'll keep 2 places past the decimal because that's how carefully they measured. There's other ways called significant figures to figure it out, but this logic will work for us now. That would be cubic centimeters. What is its mass? Well, if you have 12.81 cubic centimeters of gold, and gold is 19.3 grams per every cubic centimeter, 19.3 grams per every 1 cubic centimeter. I just take that number that's still in my calculator, multiply it by 19.3, and I should get 247.28. I guess it'd be 0.29. I really don't care how we round. Let's see, cubic centimeters crossed off, grams is our only answer. Bottom of the page, focusing on this, that says that we have to have our reasoning. When we're looking at particle diagrams, the mass is strictly based on the number of dots. How come? Because they're saying all these dots, all the particles of the same size have the same mass. Volume has to do with how much space it occupies. Box occupies. The density is a ratio between them, but since we don't have any mathematical concepts, it's going to have to be about the arrangement of these particles, how tightly or loosely they are packed. So A versus B, when I'm looking at A versus B, number of dots, B has more dots. My reasoning would be B has more mass because it has more dots. A versus C, once again, you can count that even though they're the same size, that's not what they're asking. The math says when we're comparing mass, C has a greater mass because it also has more dots than A. Volume's how much space it occupies. So we can't just say big, because when we talk about big, sometimes we're talking about weight or mass. This is about the volume of the space it occupies, the size of the box based on how much space it occupies. A is less than B. B is a much bigger box. A is equal to C. They both occupy the same amount of space. But when it comes to arrangement or density or arrangement, when I look at A and B, even though they're different sizes, they are arranged exactly the same, packed in just as tightly, so their density for A and B is equal. Yet for C, even though they're the same sized box as far as volume goes, since the particles are packed in more tightly, it will have, C has a greater density than A.